Welcome to a deep dive into the world of Mosfet, a project brought to you by the dedicated team of VIJAY Prakash, AAYUSH Sagar, ABHIJAY PANSARI, SINGH, and VAIBHAV SHARMA. Mosfet, an acronym for Metal Oxide Semiconductor Field Effect Transistor, is a fascinating subject. It's a type of transistor used for amplifying or switching electronic signals. The basic structure of a Mosfet consists of 3 layers. Picture a sandwich with the bread being the P-type semiconductor and the filling being the N-type. This configuration is called the PNP structure. The N layer in the middle has 2 heavily doped regions, the source and the drain, with a lightly doped region in between. Over this N region, a thin layer of silicon dioxide or CO2 is grown. This acts as the gate oxide. The gate electrode, usually made of polysilicon, sits on top of this oxide layer. Now, let's delve into the working principle of a Mosfet. It operates by varying the width of a channel along which charge carriers, electrons, or holes flow. The charge flow is modulated by applying a voltage to the gate, which in turn controls the conductivity of the device. Mosfets come in 2 main types, the depletion mode and the enhancement mode. Depletion mode, Mosfets are normally on devices and a voltage applied to the gate turns them off. On the other hand, enhancement mode, Mosfets are normally off devices and a voltage applied to the gate turns them on. These versatile devices find applications in a wide range of fields. They are used in digital and analog circuits, power electronic devices, amplifiers, and even in the automotive industry. The future of Mosfets is as bright as ever. With the advent of nanotechnology, we are seeing the development of nano Mosfets. These promise to revolutionize the semiconductor industry with their potential for higher performance and reduced power consumption. To recap, Mosfets are transistors that operate by varying the width of a channel along which charge carriers flow. They come in 2 types, depletion mode and enhancement mode, and find a wide range of applications in various fields. With the development of nano Mosfets, the future looks promising indeed. That wraps up our exploration of Mosfets. We hope this project by VIJAY Prakash, AAYUSH Sagar, ABHIJAY PANSARI, SINGH, and VAIBHAV SHARMA has given you a deeper understanding of this fascinating subject. Well, we're not quite done yet. We've got a bonus scene for you where we'll discuss some fascinating facts about Mosfets. Did you know that the first Mosfet was actually invented by Mohammed Atallah and Dawon Kang at Bell Labs in 1959? That's right, this essential component of modern electronics has been around for over 6 decades. And the Mosfet didn't just fade into obscurity. Today, it's the most widely manufactured device in the world. In fact, it's estimated that between 1960 and 2018, a staggering 13 sextillion Mosfets were manufactured. That's 13 followed by 21 zeros, if you're curious. Stay tuned for more intriguing facts and insights about the world of electronics. Now that we've delved into some interesting facts about Mosfets, it's time to take a closer look at how these incredibly small devices function. We're going to break down the structure and basic function of a Mosfet using a schematic diagram to help illustrate these concepts. The Mosfet is composed of a P-type semiconductor, which can be likened to the bread of a sandwich, and the N-type semiconductor representing the filling. The gate oxide, usually made of silicon dioxide, separates the gate from the body of the Mosfet. Now, let's talk about the 3 important parts of a Mosfet: the source, drain, and gate. The source and drain are the terminals for the current to flow through. The gate, on the other hand, is where we apply voltage to control the flow of current. The magic of the Mosfet lies in its ability to control the flow of charge carriers. By adjusting the voltage at the gate, we can control whether current flows from the source to the drain or not. It's like a tiny electronic gatekeeper. So that's the structure and basic function of a Mosfet in a nutshell. This tiny device, with its ability to control electrical current, truly holds the key to the functioning of many of the electronic devices we use every day.